We're on worksheet 51. We're working with Pythagorean Theorem. I highly recommend you have a calculator. It says the first set we're going to find the missing side of each triangle and round to the nearest tenth. How many decimal places is that? Nearest tenth. One decimal place. Now, before we jump into this, let's talk about this whole a squared plus b squared equals c squared. What kind of triangle do I have to use Pythagorean theorem? Has to be a right triangle. Okay, perfect. Now, what are a and b? Like, they can't just be any random sides. The legs. How do you know which ones the legs are? Okay, the legs are shorter than the overall hypotenuse, right? So that you're telling me this is the hypotenuse, and you're right, it has to be the longest side. Hypotenuse, and it is the longest side. Okay, so hypotenuse, longest side, these are the legs. So if we have a bunch of numbers, we know the legs are the two numbers that are smaller than the side C. If you're looking at a triangle, the legs come off of the 90-degree angle. That's how I know these two are the legs, because I know 12 is smaller than 13, but I don't know if X is going to be bigger or smaller because it doesn't have to be drawn to size. So I know that these are the legs because they're off of the right angle. Hypotenuse is always opposite the right angle. All right, so A and B have to be legs. Hypotenuse is always the longest side, opposite the right angle. Okay, got it? So looking at number one of the issues, I feel like people just jump in and they do 12 squared plus 13 squared. But these are the legs, right? And this is the hypotenuse. So it is going to be 12 squared plus x squared equals 13 squared. All right, so you've got your calculators out. You throw your numbers in. This would be 144 plus x squared equals 169. Now, in order to get x by itself, I'm going to move the 144 across this line, change the sign. So I'm going to subtract it. And I get my x squared, and it equals 25. So double check your math. And then how do I get rid of the square? I'm going to come in and take the square root of it. So when I go to take the square root of both sides, the square and square root cancel. That's the inverse. And then the square root of 25, that's actually a perfect square. So x is 5, because 5 times 5 is 25. We're looking for accuracy, and you should have a label on this. So it's not just 5, but 5 inches, since we know it's in inches. Okay, now if you look at the next one, do you see that you have the two legs there? So it'd be 4 squared plus 3 squared equals x squared. So you should be good on this one. Same idea to finish it, but we don't have to do the subtraction. All right, 3 and 4 have decimals, and that's okay. You're going to put them in, remember, round to the nearest tenth. If you jump down to 5 and 6, it says find the missing side of each triangle. Again, round to the nearest tenth. Okay, so pretty much the same idea. Pay attention to these both are your legs. So this is just like number one. This is your hypotenuse. Okay, now, remember, we're just popping through to do a little of each. So please stick with me. Don't ignore this and move on and keep working so you don't know how to do this section. Down here it says find the missing side of each right triangle. C is given as the hypotenuse. A and B are the legs. Again, round your answer the nearest tenth. Okay, so when you go to look at this, this is A, this is B. I'm sorry, this is A, we don't know B, we know C. So I have A squared plus b squared equals c squared. So that would be 11 squared plus b squared equals 15 squared. That's the idea. And then you're going to solve this just like you did number one. Okay, I want to jump to number 8. I know you can finish this one. Number 8 has this square root in it, and I want to make sure we talk about that. So I've got b and c. I'm missing a, one of the legs. So it would be a squared plus the square root of 6 squared equals c squared, which is 4. So when I go to put this in the calculator, I'm just going to get out 6. And here's why. A square and square root are inverses. Isn't that, I'm going to slide this up, isn't that what we did here? We canceled the square and square root. So the square and square root will cancel. But if you're uncomfortable with that, and you type in the calculator the square root of 6, and then you square it, you'll get 6. I mean, 6 squared is 36. The square root of 36 is 6. So that's why we get 6 there equals 16. And then again, I'm going to let you guys go ahead and finish that. Now, if you would kindly flip it over to stick with me, let's look at number 9. 9 through 12 ask you to tell me, is it a right triangle? So you're not looking for any missing pieces. I'm giving you a triangle, and I'm asking if it's a right triangle. If it's a right triangle, then a squared plus b squared should equal c squared. This is the converse of the Pythagorean theorem. Knowing that if the two legs squared, or the two smaller sides, equal the bigger side, then we know it's a right triangle. So if we look at number 9, the legs are the two smaller sides, the 9 and the 12. So 9 squared plus 12 squared, does it equal the longest side? I don't know if that's a hypotenuse until it's a right triangle. It has to be a right triangle to have a hypotenuse. Okay, so type this into your calculator. I don't mind, you need to show this and then show what you got out. This is 81 plus 144, and we add that up, we should get 225. So I want to see your original setup. You can then jump to that. No one wants to tell me that I wrote 222. All right, 225. All right, and guess what 15 squared is? 225. So this is a right triangle. So you need the proof. Show the setup, show what you got, that's the proof. Now, if this was something like 220 equals 225, I'd put a slash through it and know it's not a right triangle. Now, not only is this a right triangle, this is a Pythagorean triple because all three sides are whole numbers. Okay? All right, now I want to talk about number 10 for the sheer fact that it has a root, but there's more to it. Number 11 has a root, but I'm concerned with this one. So, what is 2 squared roots of 39? Is that one of the longer sides or one of the shorter sides? So type in your calculator 2 square root 39. And the approximation is about 12.49. Okay, so that tells me this is one of the shorter sides. So when I go to do this, it's going to be 10 squared, because I need to go back to the original. 2 square root of 39, but I have to put it in parentheses squared, equals 16 squared. So honestly, this is my concern right here. This is an issue. Now, 10 squared is 100. And I believe 16 squared is 256. Yes. What is this? Take a minute, put this in your calculator, and tell me what you get. I'm expecting maybe a right answer, but I'm expecting some wrong answers. So here is the issue. When and if I put this in the calculator, the 2 square root of 39, even if I close those parentheses and I put a power of 2 on it, this is the issue. I get 78 because the calculator is only squaring this. The square and square root cancel, and 2 times 39 is 78. You actually would have to tell your calculator, I'm hitting insert, you'd have to put parentheses in front of all of this. And even if I do that, I'm still going to get it wrong. Look, I still get 78 because I didn't close them. So on this type of calculator, it's often done wrong. So you close the square root, but you also have to, oh, I have ink on here, that's what that is. You close the square root, but then you have to say, hey, I want the whole thing, the 2 and the square root of 39 squared, okay? So it's really important that you would do that, and that gets us a very different answer. Okay, so how can I avoid that? Because it's likely that we're probably going to forget that, right? How can I avoid the extra parentheses? Because in my calculator, I need 2 sets. And a lot of times people forget that second one. If you go back and just put in 2 times the square root of 39 like we did from the beginning, and I'll close that. This gives me that decimal without rounding it. If I just take that answer and I say square that answer, I get that nice whole number. Do you see how I get 156? Now, if I took my rounded answer, 12.49, and I square that, see how I get a decimal? It's pretty close. So if you want to avoid it, put in your number, and then if I just hit the square button, it brings up my last answer and squares it, meaning the calculator remembers that number. It doesn't round it or anything like that. Okay? So I wanted to go over that. If we add these together, I get 256 equals 256. So that's another one that is a right triangle. Now, is this one a Pythagorean triple? I know the worksheet doesn't ask that, but I am. Is it a Pythagorean triple? Well, it's a right triangle, but are they all whole numbers? No, so it's not a Pythagorean triple. Okay?
I thought it was only when it's squared into it.
So it has to be a right triangle. Both of these are right triangles, but a Pythagorean triple is more specific that they have to be whole numbers. And this one, we rounded. It's not a whole number. Okay, you have two more like this. This should not be an issue because there's no number out front. And down at the bottom, state if the three lengths form a right triangle. They just didn't give you a picture, folks. So if I would look at this, this must be A, B, and that's C because that is the longest side. So same thing, show your Pythagorean theorem, right triangle or not a right triangle.